Let's talk about identifying right triangles given their side lengths. So we are going to be needing to use the Pythagorean theorem for this because the Pythagorean theorem is all about right triangles and their side lengths. So let's begin by remembering a couple things. All right, so the Pythagorean theorem says a squared plus b squared equals c squared. And you need to remember that c has to be the longest side. And then also that the Pythagorean theorem only works with right triangles. So hopefully that's pretty familiar to you at this point. The other thing that will be helpful with this lesson is to remember what opposite operations are. You won't need all of them, but I'm going to give you some to kind of lead you to the one that you will need. So opposite operations, for example, would be like addition and subtraction. If you pick a number, add 3, and then subtract 3, you're back at your original number. Those are opposite operations. Multiplication and division are also opposite operations. Pick a number, multiply by 2, divide by 2. You're back at your original number. The one that you're going to be using today is that if you square a number and then take the square root of a number, you have gotten back to your original number. So squaring and taking the square root are also opposite operations. So choose a number, square it, then take your result and take the square root. The only thing that could happen with this is if you choose a negative number and square it, you end up with a positive number. And then when you take the square root, you might not know that the original number was negative. In this case, that won't impact what we're doing because we're talking about side lengths of triangles, and side lengths of triangles are never negative. We're talking about distance, which is a positive concept. Direction is when you start throwing in the potential for negatives, and we aren't talking about direction, just distance or side lengths. So squaring and square rooting are opposite operations. They undo each other. So let's look at a few examples and you'll see where that comes into play. All right, so our first example does not include a square root in our set of numbers. I wanted to give you kind of an easier one to start with, and then the next one we'll throw in a square root as a side length just to show you what that looks like. So the directions say determine if the 3 side lengths will form a right triangle. So the side lengths 9, 15, and 12 will make a triangle. We just don't know if there's a right triangle there. So because the Pythagorean theorem only works with right triangles, we can use the Pythagorean theorem and see if it works. If it makes a true statement, then we know we have a right triangle. So remember, we have a squared plus b squared equals c squared. And that is kind of what we're wondering here with this group of numbers. So we're going to be putting a question mark over the equal sign. We definitely want to recognize that 15 must be our C since it's the longest side. So we can put in 9 for A and 12 for B, or switch that around. That doesn't matter. But the one that does matter is C. It must be our 15. So what we have now is 9 squared plus 12 squared on one side, 15 squared on the other, and we're wondering, does this end up becoming a true statement? 9 squared is 81, 12 squared is 144, and 15 squared is 225. So now we just need to find out, does 81 plus 144 equal 225? And the answer is yes, it does. We get a true statement here. So now we know that the Pythagorean theorem works. We get the result of 225 equals 225, but that's not how you want to answer the question. You would want to say, yes, this is a right triangle. Just to show that you know that is what you were trying to find, not something like 225 equals 225. So this would be your answer to example 1. So example 2 says, will the side lengths 6, 18, and the square root of 288 form a right triangle? Basically the same question, just worded differently. The other thing that's different though is now instead of having whole number side lengths, we've been given a square root of a number. And we do need to figure out which side has to be C, which side is the longest. Clearly it's not going to be 6. It's either going to be 18 or the square root of 288. So you would need to know what the square root of 288 equals approximately. If you've memorized your squares, you might recall that 17 squared is 289. So if 17 squared is 289, the square root of 288 is going to be just a little bit less than 17, which makes 18 our largest side. So 18 is going to be C when we put it into the equation. So again, we have a squared plus b squared equals c squared. Doesn't matter which number you put in for a or b, we just know that c has to be our 18. So it's going to be 18 squared on that side. On the left, let's go ahead and put the 6 in for a, and we'll use the square root of 288 for b, and we're going to square that. So when you square a square root, that might look a little intimidating, but again, remember what we talked about at the beginning of the video, where squares and square roots are opposite functions, and they basically cancel each other out. So if we have an original number of 288, we take the square root of it, and then we square it, we're back to 288. So the square of the square root of 288 is just 288. 6 squared hopefully is pretty easy for you. And maybe you even have 18 squared memorized. And I forgot to put my question marks there, but we are wondering, is that true? So we need to kind of recognize that with the question marks. All right, so does 36 plus 288 add up to 324? And the answer is yes, it does. So again, we have a true statement, which means again, we do have a right triangle. So just make sure you finish it by saying, yes, this is a right triangle. Don't stop at just saying 324 equals 324. You need to state in words that you know what that means, and that means that we have a right triangle. So just kind of a quick review. If you see a square root as one of your side lengths, don't let it bother you. It's actually easier than having 18 squared memorized. I hope you already have 6 squared memorized. But when you have a square root and you square it, it's just that number. So it's actually easier than it looks. All right, let's do one more just for good measure. Well, the side lengths of 7, 9, and the square root of 15 form a right triangle. Step 1, figure out which side is the longest side. Definitely not 7. Let's see if it's 9 or the square root of 15. The square root of 15 is slightly less than the square root of 16. So this is going to be less than 4 because the square root of 16 is 4. So this is our longest side. So let's use 9 for our C and see if we get a true statement. So we can use 7 as our A, square root of 15 as our B, and 9 is our C. And this is what we're wondering, is this a true statement? So 7 squared, 49. Square root of 15 squared, the square and the square root cancel each other out, so we end up with just 15. 9 squared is 81. So now we're wondering, does 49 plus 15 equal 81? And the answer is it does not. 49 plus 15 gives us 64, which is not equal to 81. So while these 3 side lengths will form a triangle, they will not form a right triangle because we did not get a true statement. So you would want to end this problem by saying not a right triangle. If you get a true statement, the Pythagorean theorem worked. And since it only works with right triangles, they would have to be a right triangle. You get an untrue statement, even though it still would be a triangle, it's just not a right triangle.